involved in space aspects and participated to the definition of the European space policy from its early days. Hello, Mauro, and welcome to this conference.
Thank you very much. I hope you can hear me. Can you confirm?
Perfectly, yes.
Very, very good. So thank you very much.
Hear you and see you also.
Okay, excellent, excellent. So, first of all, I would like to thank you for inviting me to this event on climate science from space under the aegis of the Portuguese presidency. So it's really a pleasure to be here with you. I have a PowerPoint presentation. I think it should be uploaded from your side. Can you confirm that? I don't see it yet. Yes, here it is. So here is just the title from my presentation. So it's leveraging Copernicus products and services and its role in the climate transition as part of the European Green Deal. As said by you, I'm Mauro Facchini. I'm coming from the European Commission, where I'm the responsible for Earth observation. I'm the manager of the Copernicus program. But let's go directly into the presentation. So trying to move, so move to the first slide, and the first slide is showing what is Copernicus today. So Copernicus today is a system where we have an infrastructure with satellites that are called sentinels, but also contributing missions. And these are feeding a series of services that cover different areas, from land to atmosphere, marine aspect, but also climate change, emergency, and security. And this will also provide, also fusing with in situ data, added value products that could be used for different communities of users and also for a downstream market. So the next slide is now showing how we decide to generate the different products. Here at the right-hand side, you see a light blue circle where it's indicated users. Use is very important because we say all the time that Copernicus is a user-driven system, and this is the reality. Because when we look on the different aspects of the program, so the Copernicus space and in situ data, the services and the downstream services, there were input from user requirements at all levels. So user requirements are needed in order to identify which kind of data we want to observe from space or from in situ. They are very useful to define which are the services, so the products that have to be generated by the different services, and also at the downstream level, because there might be some products that have to be adapted to specific needs. And so it's very important to listen to the users, but at the same time to make the user take up everything that is generated, and this is very true in all the aspects. And as it's the subject of today, also on climate change matters. But I will come later to this aspect. So where is it framed what we are doing today? The priorities we have at present in Europe, and in particular here in Brussels, is to think about a Europe that is moving, so that is in transition. And so everything that we are trying to do is in support of a green, digital, and resilient transition. And here you see really some elements that are also very, very close to what we are discussing today, because discussing about climate indeed is about being green, but also being resilient with something that is changing every day, and where we have to be able to react in the best way, and also by using digital technologies. So this is extremely important for everything that we are doing in this respect. For this reason, we are looking on the way to make Copernicus progress. So today it's recognized as a success. It's the European Earth observation program, probably the most advanced in the world, as is said in many cases. The first priority is indeed the continuity of what we are doing, because there are not just providers that have been invested into that, but there is also a full amount of communities, both users but also industries, that want to get in a continuous way all the data that are generated until now. But we have also to think about how to make some progress. And here we can see 4 blocks in which we can come in: data acquisition, the services, access and distribution, user uptake. So let's see very quickly which are the areas in which and the activities that we want to conduct in order to evolve in this respect. So concerning the observation, the satellites, indeed we want to continue the Sentinel missions that are very successful. We have already 7 satellites flying, and so we are very happy of the on the way they are working for the time being. But at the same time, we are looking into some new priority needs. So we have run long, I would say, interaction with user communities, and we came up with 6 priority challenges that should drive also the definition of new potential observation capacities. And here you see these 6 families. So, and you see the relevance that they can have also to climate change, all of them. So emissions and the effect on climate change, effects of climate change, highs and hydrology, and also this is very much linked to the climate change. Agriculture and urban management, again, is something where the climate is really a driver. Food security, soil and minerals. Food security, again, is an issue that is very much driven by climate. Soil vegetation, ground motion, and so on. So how this has been concretized? This has been concretized in the definition of 6 potential new missions that should be put in place. Here you see the acronyms of these missions. So it's a mission for the CO2 monitoring. It's a mission for polar ice and snow topography. Then there is a mission for sea ice, sea surface temperature, salinity. A radar mission for observation of vegetation, but also at a very low level. We are trying now, our objective is to finance all these activities, but indeed we are looking exactly into the budget. We are discussing mostly with ESA on the best way to go forward. But we are already also discussing with the industry in order to be ready to provide some new solutions, and maybe some of further colleagues speaking in this panel will get into that. I see Massimo that will follow me and might detail on some of these aspects. But it's not just the observation that has to be improved, but also the services that have to be generated. And actually, there we have 2 drivers: so the content and the way in which they are generated to take up innovation capacities. Indeed, we are looking at new things that were not provided by services up to now, but should be provided as a new thing or in a better way in the future. Here, I will not get too much into all the aspects. I will simply detail on the CO2 emission monitoring is something that was not very much detailed up to now, but will have a key role in the future services that we will be providing. And the fact that we are planning also to have the launch of the CO2 satellites in the time frame 2025-2026 will help also in providing this kind of monitoring in support of CO2 observation and climate change monitoring. But it's not just the content, it's also the innovation. So how the data, the information generated by these services could be provided. And there, we don't have to miss the train of the digital change. There we have new capacities, high-performance computing, artificial intelligence, in the future even quantum computing, how all this technology could be used in order to improve how we ingest all the data we have, the way we process them, to generate products in the different areas. So it's a challenge, but we are working into that. There is also a new concept of Destination Earth that where we would like also as a commission to organize a digital model of the planet. So some digital twins of our planet, and to try to understand how it is today, but also how it will evolve in the future. And one of these digital twins will in particular look on the climate change, so on how the climate might change in the future based on the observations that we have on our planet. The third aspect, after the data acquisition and then the services, is the data and information access. It's not just important to generate data, but also to be able to process them and to make them available. It has been, I would say, one of the gaps that we had initially in Copernicus, but then it was improved over the years. So we know that we have petabytes of data and archives. We want dynamic information, and we want really to distribute this data as much as possible. So we have to find solutions. We look into what was called the DIAS, so this structure, this system for data and information access. We're looking into concepts like data cubes in order to provide information. And as I mentioned before, there is also this concept about destination Earth. So how to provide the data as a digital modelization of our planet. And the fourth block, it's about how all this should be taken up by the market. So it's fostering the uptake and how to push for the downstream segment of Copernicus. So it's very important to turn the Green Deal and digital agenda into business development opportunities. We are there to do that. We are pushing into that, and we want really to remain a global leadership as Europe in this level. And there we have different strands that we are following. So first of all, we are involving in our activity the GSA, so the activity that was initially in charge only of Galileo, but now will be renamed USPA, and will support also the market uptake of Copernicus. We are creating a structure that is called the Copernicus Knowledge Center on Earth Observation. Actually, it was launched 2 days ago, where we will look much more closely to the needs of EU policies and how to better serve them with Earth observation capacities. Indeed, we look into research activities, trying to match better what is done in programs like Horizon Europe or Digital Europe with what we are doing in space, and particularly in Copernicus. And then a new initiative is called Cassini, also linking with the European Investment Bank in order to foster the activities in SMEs and scaling up their capacities. So this slide, I will not get into that, but it's already summarizing some of the things that I've mentioned before for the different 4 blocks. Now, getting closer to the climate change aspects. Indeed, climate change is one of the elements of Copernicus that is very important. It's where we have done many things. We are working with data suppliers, but the data actually are feeding a climate data store infrastructure, and on that basis we can have information. And this information can be either done for monitoring, so we have different reports, so the European State of the Climate, and I think ECMWF is providing this, the same also in these days, the last one, but also to feed different areas, different communities where climate change has an impact. And here you see some of them. So, for example, you can see that the observation that we are doing can give information in infrastructure and transport, biodiversity, energy, disaster and risk reduction, health issues, water management, insurance domain, coastal areas, agriculture and forestry, tourism, and so on. This is just a subset of different areas where we can give really some input. But these are not just words. Actually, there are already activities that are using this kind of support. And here we have just a few examples of some sectoral impacts. And for example, you see that there are activities that are run in support of biodiversity in Costa Rica, really looking at data coming from Copernicus observations, and to really to look into this to the change of biodiversity in that region. Then you can have the impact of climate change on some industry. We see, for example, the cotton industry that is indicated on the bottom. So really to see how the climate conditions can influence industrial production. Climate hazards is also an impact that is very important for the financial sector in order to try to understand which should be the primes, where they have to intervene in their strategy. Energy and wind industry as well, through Earth observation, is trying to give more precise details about the wind speed in different areas. So where to really put the windmills in order to generate the energy, to establish exactly the amount of wind, of the power of the wind, and to estimate the energy power that can be generated. Food security, extremely important. Looking into droughts, into rain, and so on, to really to try to anticipate the issues that might happen on the production, in particular in areas that suffer a lot of this situation, and I would say mostly for the African region. And then other aspects, we're looking, for example, at the coastal zone, the coastal flooding. Here it's indicated in Ireland, but this is very much important everywhere. So the change of the height of the water is really important in order to see how our activities should develop. And all these activities are really taken up by some companies that can really already work in these different areas and provide really precise information in this respect. I will conclude with a slide that actually is the big challenge that we have, is the CO2 observation. So this CO2 is really the novelty that we are bringing into Copernicus. It has quite important visibility into that. The idea is that we want to mix the capacity of observation with new satellites, maybe also combining them with observation from other countries, with in situ observation that can be found by different networks, to fuse this data and to have some engineering, not just to identify what is the level of in the atmosphere, but really to identify which could be the sources of anthropogenic emissions. And this would be very important for different aspects that could be either global or local. This will not replace the self-reporting that is still expected by countries, but it will help either to feed this self-reporting, and in some cases also to confirm or not this self-reporting. I think, and we believe that this new system that we will put in place, and hopefully not just as a Copernicus system, but as a system that might become global, so integrating also capacity with other countries, will really help to defeat, or at least to reduce the climate change, and in the future to have a better situation for all of us. With this, I would really thank you for your attention, and I will pass the floor back to you. Thank you very much.
Thank you so much, Mauro. Thank you. Let me just share with you this information, because this is the last day of this conference. We have a whole afternoon to get along with the research and the knowledge and the studies about the other speakers. But this conference on climate from space continues to raise and to gain interest, and there are still people subscribing. That's absolutely amazing. So the number of the people that's on the audience continue growing. And I remember once again that on the chat box, everybody can write the doubts and all the questions they want to see answered by our speakers. So therefore, now we have another guest, Ana Pinheiro Privet. She's a senior program manager with Amazon Sustainability Group, a program that, oh, no, I'm jumping. It's not your turn, Ana Pinheiro. I wanted to go fast, but no. Ana, keep calm. It's not you now. It's Massimo Comparini, right? Massimo is a Deputy CEO and Senior Executive Vice President Observation, Exploration and Navigation Business Line at Thales Alenia Space. Massimo holds a master degree in Electrical Engineering, Remote Sensing and Radar Systems, and a degree in Strategy from Graduate School of Business at Stanford University. Hello, Massimo, and welcome. You are here to share a little bit more about space technologies for a sustainable Earth, the status and the road that we all have ahead.
Yeah, good afternoon, and I hope you hear me well. Just give me okay.
Yes, perfectly. Thank you.
Okay, wonderful. So thank you, and good afternoon, the people that lead us and the panelists. And I'm of course glad to give just a snapshot after Mauro, after his institutional speech. It's a fact that I think I can control myself the presentation. Okay, it's a fact that that has been always regarded as a strategic activity. Is today it's in a new phase, new technology, new realizations, new architectures, all of to support new services and new missions. If you can, please go through the presentation. It's in the last decade, in the last 10 years, we really had an incredible richness of new sensors and new satellites in all domain to globally communicate, to observe the Earth from space, as well as to know exactly where we are. So telecommunication, observation, and navigation, single domains that altogether make really important transition to a digital age through space technologies. So a new space industry emerge, and this innovation momentum, it's really make a change in the industry and how the industry may respond to the challenge that we have for a sustainable planet. It's really incredible powerful how the everyday life, critical activities, economic activities, and scientific activities relies today more and more on space infrastructure and services. And it's a fact that to support the SDG, the Sustainable Development Goal, we cannot miss the contribution from space technologies. So if you can progress the presentation, please. It's a kind of space democratization where we have more and more players in the field, private players, public-private partnership, and of course, I think as presented before by Mr. Facchini, Europe really plays a big role, a very important role in a phase that we can call space economy, we can call democratization of space. At the end, is space giving a more and more impact on our economic and sustainable activities. And Earth observation, as has been already said, is clearly a domain very important in this respect. Space to observe and protect is one of our motto. And the reason why it's so important is very simple. We don't have a planet B. We need to address the challenges to build up a sustainable planet, and we need to use the best of our available technologies today. This is for, of course, all humanity and also for the next generation. It's extremely important to act and to act now. And the Copernicus program that has been mentioned before and during those 2 days, it's an example of how Europe may contribute with a flagship program that has already contributed in the past years and that is entering with this extension phase in a bigger contribution in the coming years. So if you can progress with the slides, I think, yeah. Since 2014, we have space asset, the space sentinels built through the European Commission and, of course, the role of the European Space Agency to support a number of services, atmosphere monitoring, ocean and sea monitoring, land monitoring, emergency management, of course, plenty of information for climate change study and modeling, and last but not least, security in a broad sense. So we learn in the past years the impact that those technologies, those instruments, this program already gave in the perspective to monitor our planet, the change of our planet, to understand the effectiveness of the remedies, specifically and especially important for the climate change. Of course, we are glad as industry and as a Thales Alenia Space that we had a very important role in the first phase. We were prime contractor for Sentinel-1 and Sentinel-3. So a batch of Sentinels using radar technologies, using optical technologies to monitor the planet, as well as a large contribution in advanced sensors and payload in radio frequency, in microwave for Sentinel-5P to support the monitoring of air quality, Sentinel-6, a reference topographic mission. It's really, I think, the best translation how our sensors, our space technologies are fundamentally important to observe and to protect the planet. And of course, last but not least, it's important to mention the role that we traditionally have on the Meteosat satellites, which is, through the generation, is the infrastructure built to understand the meteorology dynamic and, of course, to understand the climate change issues at the best. But Copernicus is looking ahead. So we have a extension of the program with new missions, and that will generate in the coming years a huge variety of different data, space big data, that will definitely be fundamental to take the challenge that we debate also in those 2 days. Through missions like CHIME for agriculture and biodiversity management, mission like CHIMR, which is fundamental to measure and to monitor sea heights and sea surface, radar mission like ROSEL for monitoring the polar regions, and CO2M to monitor the CO2 emissions, and Crystal, polar topographic missions. We will really generate the database to build up a digital Earth model, a digital twin Earth. This is really the best bridge between the space technology, what space can do, the digital society, how digital technologies may contribute to that, and of course, the Green Deal, all priorities of Europe in the coming financial plan, as well as the future objective. It's a fact that the generation, and of course, let me mention just very rapidly, being a radar engineer, that how space-based radar is fundamental in this respect. And of course, I'm proud that on the Italian side, we design, conceive a system like Cosmos Sky generation of 4 synthetic aperture radar, very important to monitor the Earth. We will have a huge data available. Data is not enough. We need to extract information. The new systems at institutional and private level will keep the flow of those data observing the Earth. We already see in the past years, Mr. Facchini mentioned before, the exponential growth in the use of the free and open data, for instance, from Copernicus. And this is combined with the growth of the new asset, new space asset, will generate the need to more and more processing, advanced algorithms to extract information. Information useful for the scientists, for the communities, for the private actors. So this is really a challenge, how to combine the space technologies orbiting around the Earth and the digital technologies, the digital platforms to make available those services to our communities. And again, Europe is showing the big potential that we have through master programs like Destination Earth and Gaia Phi. So again, a virtuous cooperation at political and technology level, the European Commissions, the European Space Agency, the academic and scientific communities, as well as the space industry. And just to conclude, we really believe that space and it's fundamental for a sustainable life on Earth. And in space, governments, institutions, private companies are really find a way to contribute to this challenge for all of us, habitant of the planet, and the only one that we have, the Earth. Thank you.
Thank you, and you finished with a great line. Space is life is actually the way that we have to look at the future. It's up. And now, finally, Ana Pinheiro Privet. She's a senior program manager with Amazon Sustainability Group, a program that seeks to leverage Amazon's scale, technology, and infrastructure to help create more global innovation for sustainability. Ana was trained as an environmental engineer and has an earth sciences researcher at the new University of Lisbon, we known as Nova. Hello, Ana Pinheiro, and welcome. I know that you're going to share with us what is behind the open data count and making that kind of data to share with us. Thank you.
Yeah, so I am having a little bit of trouble with the connection, so just give me 1 second. For some reason, are not showing up. But if you can show it on your side, I can just move them. That would be great. Would that work?
I don't know. Let me just find out if it's possible to see what you want to show us. You have a PowerPoint, right? You have some slides to show. Yes,
I do.
Yes, everything all right from our parts. You can go further, and we'll show the slides. Yes.
Perfect. Well, first, happy Earth Day. I'm very excited to be here, and thank you for the opportunity.
Happy Earth Day for you too. Thank you.
To participate in this event. So I thought today I would draw not only on my experience working at Amazon in leading the Amazon Sustainability Data Initiative, which is really a Tech for Good program we have developed to help innovation in the space of climate and sustainability, but also draw on other experience. So I spent a big part of my career as a researcher at NASA, at NOAA, working with data directly and models and satellites. And so later, with the Obama administration, focusing on an effort to bring to the forefront and to the community climate-related data sets that from the federal agencies to help innovate in the space of climate, again, the Climate Data Initiative. So next slide, please. Okay. So it's no surprise for anybody. We heard it over and over here today and often that we have more data than ever. Not only we have continuously new satellites being launched, but as computational capabilities are increasing, models are creating more products and more variables and increased resolution. We have a diversity of data. The data is diverse, and especially in a space like climate action and climate science, interdisciplinary analysis and cross-domain exploration is super critical. And what we see is that with all these many barriers that we are encountering to really advance this space, like the size, the complexity, and the variety of sources, the way that we've been dealing with data in the past and the processes and approaches that work no longer are effective or allowing us to really deliver on what we need. Next one, please. Next slide. What we also observe, and I think this is, again, no surprise for anybody, is that there's this constant effort that everybody out there that is trying climate have to go through this repetitive effort, right? So actually, DJ Patil and Hilary Mason quantified it. Finally, we have a reference that said, maybe there's others, but this is the one I use. 80% of the effort of actually extracting knowledge and insights from data are really focused on finding the data, acquiring it, storing it, cleaning it, until finally you can put some effort into analyzing the data and learn something from it. And what he means, if we look at it, is that the amount of effort that is spent globally by not only the research community, but the businesses and NGOs and everybody that's trying to work in this space, there's this repetitive effort that's really wasted that could be used in differentiated into creation of knowledge. So next one, please. And this is what we call at Amazon undifferentiated heavy lifting. So what we thought is, how can we leverage, like a company like Amazon and others, where the cloud is a prevalent technology building out there, how can we leverage some of the scale, the infrastructure, and the technology that is available to actually change a little bit the way we're doing things and optimize it? So the main thinking here is, let's reduce that effort and let's leverage the cloud. In this case, through this program that I'm running, the Amazon Sustainability Data Initiative, as a Tech for Good program, we're really trying to understand how do we lend these resources to the community to make this happen, and change this idea of like having to move the data around constantly, put it in a location, work directly to the extent possible with the data providers, and then have that data co-located with all the other layers of data sets that are valuable for exploring these issues, but right next to the compute, where we have, AI and machine learning and all the other tools and services that could be beneficial for this problem. Next one, please. So basically, the idea here is thinking about these huge data sets, especially from satellites. How do we reduce not only the cost and the time, but also the technical barriers that enable anyone, and we're talking about democratizing here. How do we enable anyone out there that really has an interest in working in this space in a committed way to come to the table and contribute to this innovative space and to grow it? Next, please. Okay, so just very briefly, I just want to mention the core components of what we're trying to do, and then jump into some examples how specifically with satellite observation, this is making an impact in the community, and not only in the research space, but also in the business development as well. So in this program, we primarily focus on three core areas. The first one is the democratization of data. And what I mean by that is that we work with a broad community and we work across sectors, not only with researchers in academia and government globally, but also the private sector and in general, anybody that is interested in this space. And we try to understand what are those foundational data sets that are really critical to study issues like climate change, food security, water management, right? Once we identify those data sets, and in general, they are big data sets, that's where the cloud can really play a role. We try to understand, how do we bring those data sets to the cloud, and how do we make them freely available to anybody? And I'll tell you a little bit more about that. So that's a component of the data. Let's make the data as open and accessible as possible. The second component is to recognize that the data by itself doesn't really create much value, that we really need to put tools next to it and allow people to analyze it. So we have different mechanisms to encourage that and enable the community to do their work. And the main one is we have basically a call for proposals, an open call for proposals where people can apply for grants to basically work for free in the cloud for normally a period of a year to prototype new ideas and new solutions. And then the third one is really focused on recognizing that we can move forward if we share the lessons learned and the code and whatever we can with each other. So we push this space forward faster. And so there's a big emphasis on promoting knowledge exchange. And we do that through the creation of tutorials and, again, webinars and encouraging people to share code. And very happy to tell you more about that. But that's really a core component of this work as well, working with the community to share more things for the community. Next, please. Few examples of the organizations we've been working with. So in this concept of opening data in the cloud, to the extent possible, as I said, we work directly with the data providers. And what that means is that they retain all the control and ownership of the data. We just basically cover the cost of hosting the data in the cloud, and it degress costs. So if somebody wants to download the data from the cloud, we cover those costs. And the only thing that the data provider has to commit to is that they will make it publicly available to anybody that wants to access it. So it basically has to have open licenses. And these are some of the organizations we've been working closely with and that we have now currently data in our system. We have petabytes of data available in our catalog. Everything from tag from like climate and weather. We have a lot of historical writers of weather. We have also climate projections, and at the same time, a lot of satellite imagery and other types of Earth observations. So the key value here is that once we start bringing all these data sets together in a place where it's easy to experiment and the cost of storage and acquisition is removed, we really hope that this will catalyze a lot more innovation as a result of this easy experimentation. Next, please. Okay, so one of the things that I wanted to mention here is that, and again, this is from my experience and the experience we've been having with the community in general, is that just moving data and making it open is not necessarily going to drive the changes we want to see. There's a key amount of effort that needs to be done to the data once it is collected or generated by a model before it can really generate some kind of strong uptake by the community. And that's not necessarily just an increasing, as you see from this curve, it is a very simplistic illustration. There's an inflection point after which, if we do too much to the data, we actually decrease the value of that data for the broader number of users. So the tricky thing is that in general, each data set and for different applications will have that inflection point at different places. And this is the kind of work and knowledge that can only be built collectively by the community working together. So we're very eager to encourage and continue to work with the community to understand, once we take those data sets and put them in the cloud, how do we stage them optimally so that people can easily analyze them and don't have to open and download all of the data to actually extract knowledge from it. Next one, please. And we really trust that if we make the data as accessible as possible, if we document it, if we build trust, primarily by working directly with the people that own the data and they are making it available, then at some point, then we are really enabling this space to grow by creating, letting the different users take the data to the next level that better meets their needs and the needs of the communities they are trying to serve. Next, please. So what I'm more excited talking about is really what are we seeing as a result of this, of opening data, and how are we putting data to work? So I thought I would show you 3 examples, very focused on the use of satellite-based observations and just show you what kind of impact. So as I said, we work across not only just with the research communities, but also with the private sector. And what's been really interesting is to see the uptake by a lot of startups and new businesses that once the data is freely available and open next to compute, and all those costs of acquiring the data, maintaining it and storing it are removed, they really jump into it to build new businesses. So let me show you a few examples. Next, please. So the first example I would like to show is Solcast. Solcast is a company in Australia, and basically what they're doing is they are leveraging the NOAA GOES. GOES is a geostationary satellite that NOAA has been running for quite a while. It's primarily used for weather observations and for tracking weather. And we have been storing the data in the cloud and also have a direct connection to NOAA. So the data is being updated basically in real time. So what this company has done is to build a workflow on top of this to generate not only real-time and historical, but also forecasts of estimates of available radiation. And they really support the solar industry in that way, and have been, quite successful at it. Next example, please. The other one, this is actually based on a Copernicus satellite observation, the Sentinel-2. A company called Synergize in Slovenia is taking Sentinel data 2 that they are making available on AWS to the community, and they're building basically this this monitoring system for water bodies that are at risk around the world. So they do this globally and very effectively, because again, they don't have to spend any of the money in acquiring the data and storing it, and they can provide this to the community for free. So it's a really great example and very inspiring. And the next one, please. And the last example in this set of examples is really of the expected value that can be created by opening these kinds of data sets. This is, for instance, a data set we have from USGS in high resolution elevation data. And as you can imagine, having this data set available right next to historical weather records and projections of future climate conditions, all of the Landsat, stored in our system, the potential to start to look at forecasting floods, for instance, it can be completely transformational. And that's where innovation really can happen, when you have all these conditions together in the same space. Next, please. I'm just going to mention very briefly the value of bringing data to the communities that really need it. And that's something we're really paying attention to. So one thing is to make the data out there, but there's only so much capacity in some of the communities and the research communities that we are trying to support. So groups like Digital Earth Africa are really critical for this kind of process. So we're basically their technical partner, and we're trying to help make all the data available in the African continent to support not only the science and the communities manage the impacts of climate change and the different issues related to environmental conditions, but also to support business development and in those communities, which is really critical. And the last story I would like, or case really on the value of engaging with trusted members of the community that really understand the needs that we're trying to meet, and then walk back from that. Next slide, please. And just as an example, we engaged with GEO, with a group on Earth observations, and basically created a collaboration where we committed for a period of 3 years to provide grants to these 21 projects in 17 developing countries, very focused on understand how open data and Earth observations and cloud technology in this case can really help build capacity and advance their ability to solve climate-related issues. So in a nutshell, I think my message here would be opening data is critical, but it's not sufficient for us to actually enable this value chain, not only on the science, climate science space, but also on the applications, to make sure that decision makers every day that are trying to understand how climate will impact them and how they prepare for the future really have in their hands the data they need to make those decisions, or the knowledge, the actionable knowledge. And I'll stop here. Thank you.
Nice to hear you, and all these projects to transform data in something that is very useful to change the earth and the world. And now we are going to hear and not see Ernest Teye. He's in Ghana, so we have some difficulties to have a solid communication with Ernest, and it's not possible to see him, but it's possible to hear him. So I remind everyone that he's a space systems engineer and the developer of Ghana's satellite. He's currently the anchor for the first African Constellation satellite project, which is currently hosting 7 African countries, building the first constellation of satellites developed by African engineers and scientists. He is the outreach manager of the All Nations University Space Systems Technology Laboratory, which initiated the project. Hello, Ernest. Can you hear us? Hello, Ernest. This is the time that my voice takes to cross the ocean, get to Africa. Hello, Ernest. There's no Ernest on the other side. We were so hopeful that we had so much hope that we could at least hear Ernest, but it's revealing a little bit difficult to hear him. No much for seeing him, we know that, because he has a very low traffic, a very low signal of internet, and it's not possible to connect with him with image and sound. Ernest, can you hear us?
Competitive and then a collaborative space business approach. So, thank you for the opportunity to present on this conference.
Hello, Ernest?
Hello?
Yes, can you hear us? I'm presenting you. Are you okay? Are you ready
Yes.
for this moment of sharing your research and your knowledge with us?
Yes, I'm ready.
Okay, I made already an introduction about your experience as professional and also as scientist. Do you want to talk with us about the cross-link between the competitive and the collaborative space business approach, please?
Yes. Thank you very much for the time to present at this prestigious conference. So, to introduce myself, I am Ernest Teye from the All Nations University Space Systems Technology Laboratory. Can you please move to the next slide? What you see on the slide is a little introduction about myself. So you see the picture there, and then I'm showing myself there. So Ghana launches its first satellite to space. So we're the three guys who launched the first satellite to space. Can you move to the third slide? All right. So over here, we want to talk on the space business approach as it is, the integration of human capital and monetary capital to note here. Hello? Hello? So great. Few points to note here. So space is a big business, is a risk. And space business is also changing. So what I want to look at today is two types of space business approach, which is the competitive approach. I'm on slide 5, which is the competitive business approach and the collaborative business approach. Some countries that are spacefaring, they adapt the method of the collaborative business approach, and some other countries also adapt the competitive business approach. So on slide 5, you can see the space race as it started in the 1957. And actually, we all understand that it was through competition that human beings ended in space. So in slide 6, we can also see another image which shows the space race between countries, which is actually the competitive approach for space business. So we can see, but then on the slide 7, what we see there is the collaborate. Hello? On the slide 8, you can also see the collaborative approach. And we see that basically space business can be categorized across nations in two ways. It is the competitive approach or the collaborative. The slide 10, I made a little comparison That is to compare the competitive approach of space business and then the collaborative approach of space business. So you can see that for when it is a competition, it is faster. With a competition, development is faster and then you get faster results. But when it is a collaboration, you see that the results is slow. But then on the second point, a competitive space business approach between countries and between industries or between companies is always not sustainable. But then when it's a collaboration, it is sustainable. And also you can see from here that when it is a competition, the cost is high because the company may want to pull all strings, all the consultants, the consultations. So it becomes very costly. There's a shared cost between countries and then nations. Now, the competitive approach is also not robust. Any space program that is carried out in a competitive way is not robust, it's not strong as compared to the collaboration. And also, you see that in the competitive approach, there is a sense of urgency. There is an urgency for improvement and then for development. But in the collaborative approach, improvement is a process. Approach for the African space industry need. This conference is about the synergy for a greener innovation and economy. So I'm speaking from the African perspective and how the European space program can be connected to the African space program for the exploration of space for the mutual benefit for humanity through the collaborative and then the competitive approach. On slide 12, you see what the African space industry need is a combination between that competitive approach and the collaborative approach. So there are three major points, or there are three major in Africa. First of all, we need a fast development. And second, there's a need for a space program in the All Nations University began to do in Ghana, Africa, to achieve this fast and then a low cost and then a sustainable space program in Ghana, Africa. Looking at the 14th slide 14, this was an idea started by the All Nations University, which we call the Afribility. So on the Afribility, you can see an astronaut from Africa actually mounting the Africa map or an African map like a flag on the moon. So this is what we call Afribility, which is actually Africa ability. So what we mean to do is to express that through a collaborative and a competitive approach, which is possible between Africa and then the European Union, Africa is able to demonstrate this kind of capacity in the space business. So we have the Afribility program, which is actually ongoing. And to realize that, we began the African Constellation Satellite Project, the African Constellation Satellite Project, which is actually the first time we are bringing together engineers and scientists from different African countries to build satellites to foster development in Ghana. So All Nations University in Ghana is actually pioneering this project. And the ultimate is the affability, so that one day, through a collaboration with the European Union, we will also be able to mount the flag or the map of Africa on the moon. So on slide 16, you can see the African Constellation project when it was being launched. So other countries have done. This actually an approach which is a collaborative competition that we are doing in Africa. So in slide 17, you can see the concept of what we want to achieve through this collaborative, competitive space business approach in Africa. Slide 17 is our contact, All Nations University. You can always get to us. And our vision is to have a platform for collaboration between Africa and then the European Union, so that through these collaborative competitions, we will be able to develop projects together for the benefit of humanity, for the benefit of humanity, and also to achieve the sustainable development goals for the benefit of humanity. All right. So thank you very much for the time of presentation, and you can always contact.
Thank you. Thank you so much, Ernest. It was quite an effort to hear you because the line had some short breaks, but the main point of the African view, of the perspective from Africa, it was quite important, and I think that we all could apprehend everything you said. Besides, of course, this little problem with the sound. But thank you so much, Ernest. And now time to talk with Carla Filotico. I said it okay? It was nice? She has 20 years of experience in management and strategy consulting, leads Space Tech Partners Management Consultancy practice. She has extensive knowledge of the space sector, an active member of the European Innovation Council Accelerator Jury. And Carla is an aerospace engineer with a Master Science in Space Systems Engineering. Hello and welcome. I know that you have a lot to say to us about emerging space capabilities and services for, of course, a greener economy.
Thank you. Thank you very much. And thank you for inviting me to this conference. It's my honor and pleasure to be here. So I will share my presentation. I think let's see if it's coming up. I can't see it, but I'm clicking. Yes. So next slide, please. There is a bit of a lag. So space, we have seen already through the presentations of my colleague earlier, that is already supporting the green economy on multiple axes. First of all, we have nature and biodiversity, the air marine quality, for example, monitoring the air quality or monitoring and helping detecting the oil spills on water. Sustainable agriculture, and we'll see more about that in the future, in the next slides, like supporting farmers, eventually optimizing the use of fertilizers and also providing connectivity in rural areas. And smart cities, indeed, thanks to space capabilities, you can optimize traveling routes and reduce the traveling time, or even enabling better shared mobility, which is a great trend in order to reduce the use of cars and carbon-fueled vehicles. And also, very importantly, support the smart grids, for example, by providing precise timing and synchronization through GNSS, Global Navigation Satellite Systems. Next slide, please. So we have seen already how, and especially focused on Copernicus, but actually also Galileo and EGNOS, so European GNSS services and infrastructure are key assets to support the vision for EU 2015 long-term strategy and Green Deal, which I recall we always speak about Green Deal, but Green Deal means that the statement that has been done, the EU wants to become carbon neutral by 2050. So it's a big goal that finally Europe has set as a continent to achieve such an important objective for all European, but actually the rest of the world as well. And here you see as space can be considered a sort of key element of this mechanism that can generate virtuous cycles from the strategy to supporting UN development goals, to support EU action for the circular economies across the different dimensions. And we have seen examples from my colleagues earlier, from Mauro, but also from our colleagues earlier, like for example, how the Copernicus services are supporting air quality and climate change through the provisioning of bulletins about the European state of climate, but also on a monthly basis, providing a full dashboard on climate data store with key climate change indicators monitored continuously. On marine pollution as well, so the Copernicus Marine Environment Monitoring Services, CMEMS, is actually providing daily data and information about water quality and tracking and forecasting pollutants. And similarly, that's done on the land-based, for example, across the quality of lakes, thanks to the land monitoring system of Copernicus. But let's not forget also the importance of smart cities. And as I mentioned earlier, indeed, Galileo, the usage of Galileo and other GNSS systems are more and more important in order to optimize routes, not only on road, but also on sea, and that eventually will reduce the production of fuel needed to perform the same routes, and therefore providing a key important impact to a greener and more sustainable transport. And lastly, we have mentioned about smart grid. As you know, we have seen a continuous adaptation towards more efficient and therefore more sustainable use of electricity and energy, and out of the concepts of smart grids, timing and synchronization provided by satellites is a key element to spread the development of these infrastructures. So next slide, please. Here, I would like to provide with some example on the next slide about, indeed, we always have to think when we speak about green economy, we speak about economy as well. So having a greener economy eventually means having, generating more gross value added for the entire economy. This is just one example, and as part of our studies, we do evaluate the socioeconomic impact of space activities for our citizens and businesses across different countries. But the most important is just to show a simple mechanism to see how, indeed, thanks to space assets, so there are different activities that can be improved, like, for example, in the smart and in the precision agriculture, improving having higher crop yields, which effect will indeed materialize in having more production and therefore the ability to feed more people, but with a more optimized use eventually of fertilizers, and maybe one day no use of fertilizers at all. And similarly, also better targeting the food aid in a more efficient manner. We know how food security is important as an aspect of a greener economy per se, because we also know the highest pollution-driven industry is, in fact, the food industry and the food chain. And then I would like to conclude in a more, let's say, provocative manner, because we think in the next slide about the circular economy on Earth, but actually what's happening is also a circular economy in space. And there are many new emerging space segments which are actually aiming and creating a more sustainable space environment as well. You have heard so much about the increasing proliferation of space objects. We have spoken before about new space, about the emerging new constellations with thousands and thousands of satellites being put in orbit. So there is a clear need also to clean space under so many ways, and eventually to recycle the materials that are produced for making space missions in the same way as we do on Earth when we speak about circular economy. So here it's a 360-degree approach that we have to take. So not only thinking about how to have a circular economy on Earth, but actually more and more how to embrace circular economy when we speak about space activities. And some services here are very clear that emerging even in Europe at a big and faster pace as we speak, like for example the possibility of reusing launches, so the reusability of rockets and other space systems, the importance of let's say cleaning the orbits in order to make especially certain congested orbits usable and in the future by removing satellites from if they are not able to be dismissed along their life cycles. And then eventually when we speak about using when a potential piece of rockets come back to Earth, using either the materials or the piece of the infrastructure as such. And with this, I would like to conclude potentially in time in my 10 minutes speech, saying that indeed there's a very exciting moment. It's a very exciting moment because the industry at space is actually creating more and more opportunities in order to support the policy agenda of not only the European Union, but many international countries around the world, and with more and more a common objective to make our planet more sustainable and the rest of the universe. Thank you very much.
Thank you, Carla. Paulo, now is your turn. Paulo Gonçalo, he is the Chief Executive Officer of Ultimate Power, the company behind the development of the revolutionary Ultimate Cell-Fuel Saving technology. He has a degree in engineering from Universidade Nova de Lisboa and then an Executive Master in Business Management. Hi, Paulo. You have something to tell us and to share with us about saved fuel. That's my favorite issue. Save fuel and help the environment. Save me and help the environment, of course. Welcome.
Okay, certainly. First of all, good afternoon, ladies and gentlemen. My name is Paulo Gonçalo. I'm the CEO of Ultimate Power. I want to thank the organization of this significant event to invite us to introduce you to our company that is dedicated to the design and production of hydrogen-based energy efficient systems. In this theme of this conference today, enabling solutions for climate transition, I will not discuss the space issues, but we will try to present our solutions related to hydrogen in the climate transition. I don't know if I already passed the first slide. I have a lag here. Okay. Ultimate Power was a company that was established in 2012. We operate globally in 65 countries around the world. From the beginning, the R&D was a primary driver of reaching the market with disruptive technologies based on hydrogen generation. It is disruptive because they are unique, with exceptional savings results with paybacks of the order of 12 months, and in some systems with a reduction of 80% in pollutant emissions, especially on particle material related with the use of diesel engines. Our products and service made a clear contribution towards the implementation of the 2030 Euro targets. We are making our company a benchmark in energy efficiency, ensuring a performance based on the disruptive and patent technology to optimize internal combustion engines and hydrogen production units. We achieve substantial reductions in the ecological footprint in the transport, energy, and industry sectors. Our systems use the national industry and the best and most accredited suppliers of high technology in Europe, United States, and Japan primarily. The safety of our systems is a major concern. We have an insurance that covers worldwide all our products in this aspect. Our roadmap since 2012, we started with the small devices Ultimate Cell for internal combustion engines that produce hydrogen and oxygen from alkaline electrolysis process. In 2014, we developed the equipment Ultimate Cell large engines that allow us to optimize fuel consumption up to 1,200 liters per hour. In 2018, we started a joint venture with a cement producer here in Portugal, Cecil, to optimize the continuous combustion process related with cement using hydrogen and oxygen with disruptive results that lead us to the constitution of a brand new company, UTIS, Ultimate Technology to Industrial Savings. In 2020, we created a brand new device. We call it Ultimate Cell Hydrogen Production that can produce hydrogen from renewable energies. We call it green hydrogen that could be used by our clients as a raw material. Also in 2020, we developed the new device generation 2 Ultimate Cell large engines to optimize internal combustion engines. For internal combustion engines, our main goal is to reduce energy consumption and pollutant gas emissions. How? Using hydrogen and oxygen to improve that combustion to have more energy from the same amount of fuel. This is a schematic representation of the installation of our device, Ultimate Cell, in internal combustion engines. We introduce hydrogen into the air intake of the engine. We take a very small amount of energy from the grid, electrical grid of the car to produce a very small amount of hydrogen to improve this combustion. In the internal combustion engine area, we present solutions for consumptions up to 1,200 liters per hour. We use hydrogen to ensure better combustion, to have more energy from the same amount of fuel. This patent technology, worldwide approved, reduces fuel consumptions and harmful emissions. Today, we have several certifications of all types, and we are continually adapting to the country standards where we are spreading our implementation. This is a patent technology worldwide for internal combustion engines using hydrogen and oxygen, also for the continuous combustion improvement using the hydrogen and oxygen. our 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 device was submitted to a lot of tests and is approved by a serial of several institutions worldwide with worldwide recognition. This is just an example of what our technology can do. We are using the hydrogen and the oxygen, and you can see in both photos on the left, before the using of our device, you can see the particle material resulting from the use of diesel fuel. After the installation, you can see a clear reduction on the particle material. In 2015, the City Council of Lisbon approved our device as a device that reduce harmful emissions, and in what is related with the enter on the reduced emission zone in Lisbon. After install the device, you can increase the level Euro emissions classification of a light vehicle using our device. At Ultimate Power, we strongly believe in partnerships. In 2015, we started a joint venture with Cecil, a Portuguese company that produces cement, to optimize the continuous combustion process with the use of hydrogen and oxygen. Utij was created in 2018 and has sold more than 44 equipments to the 8 biggest cement manufacturers in the world. We are working in other sectors, namely biomass boilers, municipal solid waste incinerators, and others. In this sense, we have cooperation agreements with the most varied industrial, scientific, public, and private entities that guarantee us state-of-the-art in this area of hydrogen. In 2020, we started a partnership with one of the largest American companies in the area, Plug Power, to produce containerized systems to produce hydrogen for projects that require hydrogen as a raw material for different applications, namely in the area of mobility, hydrogen refilling stations, projects related with power to gas to introduce hydrogen into the natural pipeline, and some industry applications. We already exported large systems to the United States of America for hydrogen refilling systems under this partnership, and we are currently producing them to Canada and New Zealand and other countries. This enormous task of implementing this energetic transition in Europe will create numbers of qualified jobs that will significantly impact our countries. Since the beginning of our activity, we have multiplied our working areas. We are continuously increasing our employees' numbers, which today we are already around 40 in the most diverse levels of skills and technologies. We believe in our national capacity to face challenges, and we always bet on our teamwork. Finally, the need for green hydrogen in Europe in the following years will be huge. The European economy decarbonization will only happen if governments and companies have the intelligence and believe in joint forces to achieve these common goals. The hydrogen market should lead the European economies to ensure the energy transition for a better environment and social inclusion. Thank you for your attention.
Thank you, Paulo, to share with us all these improvements and discoveries that you've made and that you're producing to turn this world a better place to live and to take care of our Earth in this Hertz Day, that is today. Now time for questions. I ask again the attention of Mauro Facchini. We have a question from our audience that it's municipalities and subnational regions will benefit hugely from Copernicus data for climate adaptation, but cannot pay for value-added service. Should Copernicus not invest more into free quality assured downstream services, in particular of public authorities?
So thank you very much for the question. Actually, in the activities that I've shown in my presentation, it was really towards the end when I was speaking about market uptake. There are initiatives in order to foster the downstream market. So to make the possibility that some companies can build their capacity and to go further with the processing of data that are generated by Copernicus. I think it was quite interesting the slide that I've seen from Anna that actually was showing the use of data from people from raw to highly processed, based also on the quality verification of that. In our case, I have to say Copernicus is stopping really at the tip of that slide. And when we go in the downstream sector, this is mostly to the market to do that. Indeed, probably we have to invest more in trying to verify the quality of that data, and to help them to check that the data are very much responding to the needs. So I think it's part of our objective for the future, really to make this more useful for the user communities.
I have another question for you, this time from Margarida. Ground truth data, field data and or digital or not, spatial and temporal, that support the development of good products generated by satellite data are critical. Satellite industry are aware of this. Our European Space Agency, EC initiatives, programs help end users to face this challenge.
So sorry, can you repeat, because I lost you at the moment.
Ground
Can you repeat the
truth
question?
data, field data and or digital or not, spatial and temporal, that support the development of good products generated by satellite data are critical. Satellite industry are aware of this. Our ESA initiatives, programs help end the users to face this challenge.
Yes, so I think that the question is mostly how we can actually use in situ data in that respect. So we have satellite data and we have other data that are on Earth, more traditional. Indeed, these data are very useful because they can be used into different versions. One is to complement the satellite data in order to have much complete information, but also they have to be used in order to calibrate the satellite data, because indeed I think on the ground or in situ data are those that have a longer history, and we have to ensure that the data generated by the satellites are really continuing that. In general, in situ data already exist in networks that are in many cases developed by member states in the EU, for example, or by different companies. And we are trusting on this existence. I have to say that we're speaking, for example, about Copernicus. It's a joint endeavor where it's true that there is the European Commission, European Union as one partner, European Space Agency and other ones, but also member states participating into that. And in many cases, these in situ capacities belong really to the member states. So it's very important that all these actors work together.
Yes, indeed. And now for Massimo Comparini, you mentioned the extension and new missions for Copernicus, as did Mr. Facchini, and the importance of collected data. Making data available is the challenge, so are scientists and business prepared for computing and treat data to produce the right impact, or is there still a way to go in that domain? You have to turn on your microphone.
The Copernicus extension, it's really a fundamental evolution of the program. Through new sentinels, we generate new data. But on the other hand, we know that the capability to use, to process, and to distribute data and information, it's passing through new ground infrastructure, digital platform, and if I could say, what we name digital ground. So it's really not only what happened in space that would be fundamental to take the challenge that we debate to those 2 days. Digital twin Earth, the capability to build up digital twins of our land, of the planet, at different scale, it is really essential. And to do that, we need to use the most advanced IT technology, so the cloud-based solutions, high power computing. And I think, again, this is the best connection of the strategy of Europe in space and in the other big pillars like digital and Green Deal. So it's really the best example of how space is going to contaminate with a lot of other technologies and how we need to have a comprehensive and holistic, let's say, progress at European level in all of that.
We have another question for you now from John Lindberg, that's in the audience. Given that there is dependence on satellite systems for obtaining the space-based data for climate models and other purpose, could someone comment on the hazards presented by ever-increasing space junk quantities to these assets? Are there plans to mitigate these hazards?
Yeah, of course, space debris, it's a concern. And again, it's not by chance that one of the emerging strategies at European level is the space surveillance and traffic management. We have, of course, at this stage, a number of actions to put in place. First of all, to know what is around the Earth and to prevent possible or potential collision that may damage our space infrastructure. And then, and this is not a technology challenge, but it's also a challenge in terms of rules and processes and procedures, is to build new space infrastructure in the coming years that are less, let's say, dangerous in terms of fragmentation. So take the challenge to build space hardware that is less dangerous in terms of possible debris production.
Thank you so much. We are running out of time only for one more question. I'm so sorry to the other speakers. And this question is to Anna, Anna Privet. Yes, Hannah, you provided interesting information on the way Amazon is facilitator for making open data count. It is easy for the space and climate communities to be aware, engage, and contribute for the Amazon initiative, or is this endeavor basically streamed and selected by Amazon?
Yeah, thank you for the question. So, yeah, this is an open program. So it's a tech for good. We're trying to work with the community and help by leveraging, whatever resources Amazon can bring to the table. So very much interested in talking to anybody that, one, wants to use the data we already have in the cloud, is open and freely available. Two, if you have data sets that are of value to the community to work on these issues related to climate change, we, as I said, have this program where if you qualify, we pay all the costs of hosting the data in the cloud and distributing it. And then we have these cloud grants, so that if anybody wants to experiment and develop new solutions, they're very welcome to apply. So yeah, I think I included my email address in my presentation. So feel free to reach out if you have any questions. And if we can help, we certainly would like to get involved and collaborate.
Thank you, Anna. Thank you to all the speakers in this panel. I invite you now to make a really short coffee break for about 5 minutes. I also would like to remember that the first 100 registrations in this conference received a small gift, a Portuguese box, so we may say, with some delicatessen. So enjoy it. If it's now the time, you have 5 minutes, and we'll come back for the last panel. Don't miss, and you already know, or you have the chat box to put on all your questions and doubts. It will be unforgiven if you'll not be with us for the next panel. See you soon.